Thanks for bearing with me, folks. This is the second half of, I believe it's lecture 12, the self-regulating economy in the classical model. So the first part of the lecture, we ended over here with the marginal propensity to consume, and we didn't go into it, so I'm going to go into it now. So there's this concept in economics called the marginal propensity to consume. And what it is the change in consumption divided by the change in disposable income. So what we believe for an economy-wide, the marginal propensity to consume is some number, would be a coefficient between 0 and 1, meaning that for every additional dollar of income people get, they will consume some coefficient of that or some percentage of that. Now, each person's marginal propensity to consume would be different based on their preferences for consumption or savings. In other words, some people will choose to consume a lot more of the next dollar that they earn, and other people who are savers maybe will choose to consume only a little bit more of an extra dollar they earn. And we could even imagine that on an individual level, a person's marginal propensity to consume could be greater than 1 if they have access to credit. But economy-wide, we do not believe that the marginal propensity to consume can be greater than 1, and it's not likely to be less than 0. And actually, economists have studied the relationship between disposable income and consumption, and it stays remarkably steady over a long period of time. So this is pretty much something that we can test with data. It's something that economists have tested with data, and the marginal propensity to consume is some coefficient between 0 and 1 for the economy. All right, so how are we going to get started with, or how are we going to use the marginal propensity to consume to develop a thing called the consumption function? Well, the consumption function has two parts. One is a thing called autonomous consumption. That's the level of consumption that exists when there's no change in income. So maybe there's a certain level, we're at a certain level of income, and because we're at that level of income, we get a certain amount of consumption. Now, the other portion of the consumption function is an upward sloping line that show with the slope of the marginal propensity to consume. So on the x-axis, we normally call the horizontal axis the x-axis, we have what we call y. Now, y doesn't mean we took what was on the y-axis here and moved it over to the x-axis. Y is income in economics. So what we're showing is income on the x-axis, and we're calling income y, and then on the y-axis we have consumption. So if we want to take a look at the slope of the consumption function, we're going to be looking at the change in consumption on the y-axis divided by the change in income, which we call y, and that's on the x-axis. So the slope of our consumption function is just the marginal propensity to consume. So our entire consumption function is equal to autonomous consumption plus the marginal propensity to consume times disposable income, or times the change in disposable income, if you like. All right, so remember we said that when we take the expenditure approach to looking at GDP, GDP is equal to C plus I plus G plus exports minus imports. So imagine that our consumption function consists solely of consumption. What would it look like? We'd have this portion over here called autonomous consumption, and then the marginal propensity to consume would give us the slope of the consumption function. Now, what if we just added planned investment as one big chunk to the consumption function? In other words, let's assume that the only thing that matters in terms of the slope of our production function is a marginal propensity to consume, and we go ahead and we add whatever planned investment happens to be to that. We would get a line over here, this blue line, that is C plus planned investment. Let's imagine that we then take whatever government purchases are and add it as a separate chunk to C plus planned investment, and we would get this red line over here. So now we're looking at aggregate expenditures based on C plus I plus G. And then if our net exports is some positive number, meaning that we export more than we import, and we add that positive number, whatever that happens to be, as one big chunk to C plus I plus G, then we get this portion of the consumption function over here. So this these lines are different amounts or different ways that we can categorize aggregate expenditure. If we're just talking about C, we're on this green line over here. If we're talking about C plus I, and I would include planned investment, then we're on this blue line over here. If we're talking about C plus I plus G, then we're on this red line over here. And finally, if we're talking about everything, all expenditures that make up GDP and our net exports is positive, we're on this yellow line over here. All right, what if our net exports is negative? Well, it's not going to change anything except for the fact that now maybe C plus I plus G plus net exports, because we're exporting less and we're importing, would be below whatever aggregate expenditures would happen to be if C plus I plus G, if we're just talking about C plus I plus G. So these are called aggregate expenditures, and we're determining whether or not what is our level of aggregate expenditures. Is it just consumption? Is it consumption plus planned investment, or is it consumption, planned investment, government purchases, and net exports? Does that make sense? So we're developing this thing we call the Keynesian Cross, and to do that we have to develop aggregate expenditures. All right. So what is the Keynesian Cross? Well, Keynes had this insight that you could think of aggregate expenditures as being the demand side of the economy, and you could think of income, Y, as being the supply side of the economy. So why would income be the supply side of the economy? For the same reason given by Say's law. In other words, when people generate that people have to do something to generate income. People have to produce something. So the income the different levels of income are produced by producing different amounts of goods and services. So as we move from left to right on the x-axis, which we're calling Y, then we're seeing our income go up. Now, what if we were to put a 45-degree line coming out from the origin? This line, by the way, Keynes called the translator line. What would the significance of that be? Well, if you can imagine folding, let's say this is a piece of paper and you drew a 45-degree line, or you kind of eyeballed a 45-degree line and you folded that piece of paper on the 45-degree line, then whatever value you have over here on this axis, the x-axis, which we're calling Y for income, would be translated onto the y-axis, which we're calling aggregate expenditures. So imagine that we've got a consumption. This green line over here is just our consumption function. At the place where our consumption function intersects our 45-degree line, levels of income would be equal to aggregate expenditures that we're showing only as consumption. All right, what if we wanted to look at aggregate expenditures as being C plus I over here? Well, then we'd be on this blue aggregate expenditure line over here, and at the point where our blue aggregate expenditure line intersects our translator line, then the amount of income that we're generating over here at this level, this is income that we're generating from C plus I, is going to be equal to aggregate expenditures that are going to be that are going to take place at the same time. There's nothing saying that these two have to be equal. It's just that they are equal when we are on this 45-degree line. So let's say we look at our measurement of aggregate expenditures is C plus I plus G. Remember, the marginal propensity to consume is the slope of our consumption function, and we're just adding the amount of investment, the amount of government purchases to that. So we're on this red line over here, and at the place where the red line intersects the translator line, we would see that the amount of income being generated for C plus I plus G is equal to the amount of aggregate expenditures at C plus I plus G. And then finally, let's assume that our net exports are positive, so they're going to add to income, because we're exporting more than we're importing. So what level of income would we be generating if our aggregate expenditures on C plus I plus G plus net exports is equal to some amount of income that we're generating by creating that much in the way of goods and services? We'd be right over here, right where our yellow consumption function aggregate expenditure line intersects our translator line. All right, so the economy could be the economy could be anywhere. It doesn't have to, we don't have to have aggregate expenditure line crossing our translator line. I mean, it could be somewhere else. So why is this important? Keynes developed this idea called the Keynesian Cross to explain what might happen, let's say, over the course of a business cycle to the economy with respect to how much we're producing versus how much we're consuming. So remember, we've got aggregate expenditures on the y-axis, and y stands for income, real GDP on the x-axis. And we earn real GDP by making things, by producing things. So the x-axis is the supply side of the economy. The y-axis is the demand side of the economy. The only time the economy's aggregate expenditures would be equal to what we are producing is at this point over here. Imagine that this thing is our aggregate expenditure line, and imagine that it crosses our translator line at this point we call E. Then pretty much everything that we're producing is being consumed, and you could think of that as being an equilibrium. Well, what if the economy was at some lower level of, let's say, production, and let's say we're over here, okay, and let's say that when we're over here, aggregate expenditures is equal to this much. How do we know that? Because this is our aggregate expenditure line over here, and so what that means is that this has to be from 0 over here to this point over here on the y-axis has to be the total amount of aggregate expenditures. Well, how does what we're producing compare to our aggregate expenditures? It turns out it's actually less than that. So that's kind of a head scratcher if you think about it, because how could we be producing less than people are consuming? So Keynes's response was, you could have had an inventory buildup in a previous period that is now, firms are working through that inventory buildup. And as they do that, what might wind up happening is we will be moving in this direction. I hope you can see this. I'm moving the cursor on the x-axis. We're moving closer and closer to equilibrium. And when excess inventories finally get down to 0, right? We have to have, if we're producing goods, we have to have inventory. If you don't have inventory, you can't sell anything. Just ask Sears. One of the reasons they're going out of business is because they never have anything in the store. But what you don't want to have is excess inventories, right? So imagine that as we moved from a lower level of real GDP to the equilibrium level of real GDP, excess inventories go down, and this might take a while to get from let's say K over here to E over here. All right, what's another possibility? I mean, if we don't have to be here at E and we can be here at K, can we be at another point? And Keynes said, yeah, why not? What if we were in an economic boom, let's say? So in this economic boom, let's imagine that real GDP is at this level over here. And so if we go up to our translator line, it looks like we're producing this much. But if we look at aggregate expenditures at this level, it only appears to be this distance from the x-axis over here to H over here. So what's happening if we're producing more than people are consuming? Then we're building up inventories. And so this is not a good thing because, again, firms have to have a certain amount of inventories, but what they don't want to do is build up more inventories. In other words, make things that people aren't buying. So if this were to happen for a little while, maybe firms would realize that they're making too much that's not being sold, and then at some point in time they'd stop production. The economy might go into a recession, and then you might be in a situation where we've gone from this level of GDP down to this level of GDP over here, and the economy has to work its way through all that unplanned inventory. It's got to get that down before we can finally get to this level of the equilibrium between what we're producing and what we're consuming. So this is called the Keynesian Cross. All right, now why is this, or how is this relevant, I guess, to talking about the economy? Remember we talked about a production function being this thing where we've got a variable input on the x-axis, let's say the number of workers, and we got how much these workers can produce on the y-axis. So imagine that the economy is in some equilibrium, but this equilibrium level of output is below where we'd like it to be at full employment. We'll call this the recessionary level of output. So how we're aggregate expenditures over here, they're over here at AE star. Now imagine we go over to the production function, and so this is how much people are demanding. How much are people actually producing? Well, because we're not at the full employment level of output, the quantity of workers that are producing is less than the quantity of workers would be if we were at full employment. So what we have to do is we've got to look at how much GDP, how much stuff we're producing when we're only using Q sub R workers. So we go along our production function, we keep moving up the production function until we get to Q sub R, and then we go over here to the y-axis, which in this case is real GDP, and this is the amount of income that would be generated during a recession. So one of the things that Keynes and Keynesian economists believe is that when the economy is, let's say, stuck in a recession, maybe there needs to be some kind of stimulus. There's got to be something to get the economy out of recession. Obviously, the private sector is not doing it. Consumption's not going up or investment's not going up. So maybe the government should do something. And since we just add G as the amount of increased government purchases to our aggregate expenditure line, then maybe we move from this dark green line over here to this light green line over here after we get an increase in government purchases. So now we get to a new equilibrium level of output. And let's assume that the amount of government purchases is enough to get the economy out of a recession. Maybe now we would be at the output level of full employment. And if we go over to our production function, we would see that because of this additional government stimulus, there are more workers going back to work. We're at the full employment level of output. How much are we producing now? We're producing at this level over here. So that's kind of the insight behind the Keynesian cross. If we marry the Keynesian cross to the production function, this shows, according to Keynes, I'm not saying that, I necessarily buy into it or you should necessarily buy into it, but according to Keynesian economists, that maybe the solution to a recession is an increase in government purchases to shift the aggregate expenditure line up and get us to a higher, employ more workers, get us to the full employment level of output, and get us out of the recessionary gap, get us to the full employment level of output. All right, so this brings up the whole idea behind the multiplier. Remember, I played you guys that rap, and there was a line the Keynesian guy was saying, multiplier, driver higher. What was the idea behind that? There are different multipliers in the economy, and I even showed you some of the estimates that economists have made for the multiplier. So we have the investment multiplier, the government purchases multiplier, the net exports multiplier, the autonomous consumption multiplier. For the sake of simplicity, and because I'm just trying to show you the concept behind the multiplier and not necessarily get into the details behind it, the way let's assume, for the sake of simplicity, that all these multipliers are identical. In other words, there's no difference between the investment multiplier, the government purchases multiplier, the net exports multiplier, autonomous consumption multiplier. They all have the same formula. What is this formula? The change in GDP, triangle GDP is delta GDP, is equal to 1 over 1 minus marginal propensity to consume times a change in planned investment. So if we get, let's say, $1 increase in planned investment, we run it through this formula, and that'll tell us how much GDP will go up. So let's assume that the government purchases multiplier is also similar to that, almost identical. The change in GDP is equal to 1 over 1 minus marginal propensity to consume times the change in government purchases. So a $1 increase in government purchases, we run it through this formula, and it'll tell us how much GDP will go up, and the same thing for net exports and consumption. So imagine that, let's make the assumption that the marginal propensity to consume is 0.6. I'm not saying that's what it is in the real world. I'm just trying to illustrate how this would work if the marginal propensity to consume were in fact 0.6. So then what we need to do is figure out what is 1 divided by 1 minus marginal propensity to consume. So 1 minus the marginal propensity to consume, if it's 0.6, is going to be equal to 0.4. So 1 divided by 0.4 is equal to 2.5. So then if we get $1 increase in government purchases according to this, that will lead to a $2.50 increase in the equilibrium level of GDP. Why is that? Because let's say the change in G is 1. 1 minus the marginal propensity to consume is equal to 0.4, right? So because the marginal propensity to consume is 0.6, 1 divided by 0.4, 1 divided by 0.4 is 2.5, so a $1 increase in government purchases times 2.5 is going to lead to a 2.5 increase, $2.5 increase in GDP. That's the idea behind it. And I think we went over this in class as well when we were talking about aggregate supply, aggregate demand, and fiscal policy. The idea is this, that if let's say the government spends $1,000 more, or $1 trillion more, $1 billion more, whatever units you want to use, then it's initially injecting, let's say, this $1,000 into the economy. The people who get this $1,000, if they have a marginal propensity to consume of 0.6, are going to spend an additional 600 of this 1,000 in the next round. So the first round leads to $1,000 worth of additional economic activity. The next round leads to another $600 of additional economic activity. If we add these two together, we get 1,600. But don't forget the people who get this according to the model. I'm not saying that I necessarily buy into it, or you should buy into it, but let's not forget that according to the model, the people who get this $600 also have a marginal propensity to consume of 0.6. So in the next round, these people are going to spend 60% of that. So we're going to get another $360 in economic activity that we have to add to the 1,000 plus 600. And so what does that give us? 1,960. And this will continue until pretty much there's nothing left. So this is how this expenditure multiplier is supposed to work in getting a less than fully employed economy out of the recessionary gap. Does that make sense? All right, I guess I'm done with this, and I'm going to be uploading this, and you guys should be seeing it shortly. By the way, this is something, a little schematic and some other notes that I'm not going to go over because we either went over it in class, or it's not really relevant. So thanks a lot, folks.